So in this video, we're going to add or subtract and simplify rational expressions. So the first example is x plus 5 divided by y plus 2 minus y minus, let me back up here, x plus 2 and then minus x minus 2 over x minus 3. Don't want to switch up x's and y's, okay. All right, in order to do this, adding and subtracting fractions, we have to have the same common denominator. So we must find the least common denominator. Okay, that's the first thing you got to do. Now, what do I mean by least common denominator? So say I had like 1 over 2 plus, 3 over 5, okay? In order to have the same common denominator, least common denominator here, I'd have to multiply the top and bottom here by 5 and the top and bottom here by 2. That way, when you multiply, you have 5 times 1 gets you 5 over 5 times 2 gets you 10, and then plus, and then 2 times 3 gets you 6, and then 5 times 2 gets you 10. And once you have the same common denominator, then you can combine together. So this is 11 over 10, okay? So we're going to do the same thing here, but instead of with numbers, it's with the letters. So common denominator, we have an x plus 2 here and an x minus 3 there. So in the same way we had a 2 here and I needed to multiply by 2 over here to add in with that 5. I've got a 2x here. I need to put a 2x here. But if I put it in the denominator, I also have to put it in the numerator to make it still like it's the same thing. Dividing a number by itself is just 1, okay? As long as x doesn't equal to -2, we're good to go. And then over here, I need to add an x minus 3 factor to make it match up. But if I put it in the denominator, I got to put it in the numerator just like I did in my little trick here. Okay? Excuse me. So now, what do I have? Well, I've got in the numerator x minus 3 parentheses and then x plus 5 parentheses minus x minus 2 times x plus 2. And in the denominator, I have the same base here and here. So I just write that just like I did my 10s. I wrote the 10 there. I have my x minus 3 and my x plus 2. Okay? So what can I do? Well, I can actually simplify the numerator. How so? Distribute FOIL here and FOIL here. Double distribute. So if I multiply x times x is x squared. X times 5 is 5x. -3 times x is -3x. -3 times 15 is -15. Now I'm going to handle this minus sign in a little bit, but for now, I'm just going to put a big old parentheses. And we'll FOIL here, that's x squared plus 2x minus 2x minus 4. Okay, it looks like the middle terms cancel. So this just gives me x squared minus 4. But what am I doing? I'm doing a negative to that. So what's that going to do to these two pieces? It's going to turn it into a negative x squared and a plus 4. Okay? And all of that's over x minus 3 times x plus 2. So now we can collect like terms. Oops. So I have an x squared and a negative x squared. Those cancel. 5x minus 3x is 2x. -15 plus 4 is -11. All divided by x minus 3 times x plus 2. Now, I can't factor the numerator, and it doesn't cancel with anything in the denominator. So this is simplified, but I need to set the bottom equal to 0. Excuse me. So when I set the denominator equal to 0, I find that x minus 3 equal to 0 and x plus 2 equal to 0. If I solve, x can't be 3 and x can't be negative 2. So my solution right here, as long as x does not equal 3 or negative 2. Okay? Let's try another one. X plus 2 over x minus 3 minus x minus 3 over x plus 5 minus 1 over x squared plus 2x minus 15. Okay. Remember, first thing you do when you're simplifying these is you try to find the least common denominator. Now this thing over here is nasty, but guess what? It's a 1 in front, so I might be able to factor this to make it a little bit better. So multiply to negative 15, add to 2. Let's see, 3 and 5. So 3 and negative 5 make negative 2. So 5 times negative 3. So 5 minus 3 gets me 2. So since it's a 1 in front, this factors to x plus 5. And then what? X minus 3. Okay? So I'm going to rewrite this. I'm going to duplicate that. All right, so I rewrite this. I'm going to delete this. I'm going to replace it with x plus 5 and x minus 3. So common denominator here looks like we need to have an x plus 5 and an x minus 3. Well, right now, we're missing a little bit. Okay. I think that's going to be enough room. What are we missing from this one? We're missing let me move that over just a little bit more. Okay, we're missing an x plus 5 here. Put it in the bottom, got to put it in the top. And then what are we missing here? We're missing an x minus 3 here, so I'm going to put an x minus 3 here. Okay, and so now I've multiplied out. So what do I have? I've got this. So I have x plus 5 times x plus 2, and then I have a minus x minus 3 times x minus 3, and then I have a minus 1 all over x plus 5 times x minus 3. Okay? So I need to multiply, and then collect like terms. So this is going to be x squared plus 2x plus 5x plus 10 minus x squared minus 3x plus 9, and then minus 1 all over x plus 5, x minus 3. Okay? So this negative will transfer into each one of these pieces. Now the middle terms, they add to negative 6x. Okay? But when I do this negative in here, that becomes negative x. Let me do this a different color. Negative x squared. And then the negative in here makes it a plus 6x. And then the negative in there makes it a minus 9. All right. Collecting like terms, x squared and the x squared cancel. 2x, that's 7x. Plus 6x, that's 13x. 10, and then minus 9 and minus 1, that's minus 10, so that cancels. So this all cancels. And so, because look, 10 minus 9 minus 1 is 0, right? That cancels. And so then it's over x plus 5 times x minus 3. Now, the numerator and the denominator, nothing cancels there. So I'm going to set the denominator equal to 0. see what are the restricted values. Looks like I cannot have -5. If I plug a -5 in there, that gives me 0 in the denominator. Here, if I plug in a 3, that gets me 0. So as long as x doesn't equal 3 or -5, looks like we're okay. Okay? All right.